Okay, so in the last video, we talked about solving all different types of equations. And in this video, we're going to take it a step forward and we're going to talk about how to solve inequalities, okay? But first, there's one thing I want to mention about equations, okay? So we're going to do a but first. I hope that didn't sound too weird. Okay, this is just a quick note about equations. We talked about solving equations, but we didn't really mention that there's a possibility that there is no solution to an equation, or there are an infinite number of solutions. So any equation, we're going to do an example with linear, but any equation. Okay, so what's an example of this? If you're thinking about two lines, okay, and you're saying that the two lines have no solution, a solution when we're talking about two lines is where those lines intersect. So think about parallel lines. If you're thinking about an infinite number of solutions, then you're talking about the same line, okay? But if we're talking about an equation, what we're saying is it's not possible for the left side to equal the right side, regardless of what you plug in for x. That's what we mean when we say that there are no solutions. So an example would be x plus 3 is equal to x plus 5. Now you may be able to look at this and see, well, if you add 3 to a number and you add 5 to a number, there's no way that you're going to get the same thing, okay? It's just not possible. But this might be a little bit easier for some of you to see, but if you are not really thinking about it that closely from that perspective and you just start solving, let's see what happens when we actually start solving an equation like this. Let's start solving in green. Okay, so the idea is that we move everything, all of our variables over to one side and all of our constants or our numbers over to the other side. So if we do that, we can subtract x from both sides. Okay, let's say that we're trying to get the x over to the left side. And if we're getting the x over to the left, then that means that we want to get the 3 over to the right. So we would subtract 3 from both sides. And if you think about what happens here, we crossed out the x here because it cancels, right? X minus x is equal to 0. But actually what's happening is on the left side, that also happens. What we wind up getting here is on the left, we have a 0. And on the right, we have a 2. And 0 is not equal to 2. So what's happening is when we solve these equations, if at the very end we get two sides that are not equal, it means that we have no solutions. So this is one example of an equation that has no solutions. No matter what we plug in for x, the left side will never be the same as the right side. Okay, another example would be if, let's say, we had 4x plus 6x minus 7 is equal to 2x plus 8x plus 2 minus 8. Okay, this is a great review of what you would do in a case like this, where you have multiple x's on one side or multiple constants. Remember, you want to combine like terms first, right? So I'm just going to put that as a note in the margin. You don't have to do it this way. Some people just subtract 2x and subtract 8x from both sides. They have all of the x's on one side, and then they combine like terms. I prefer combining like terms first so that you don't accidentally add or subtract something twice to the same side. So if we combine like terms, and I'm just going to label this 1 and 2, so that you see it's two separate examples. So 4x plus 6x is 10x. So we have 10x minus 7 on the left. And then we have 2x plus 8x, which is also 10x. And then we have plus 2 minus 8, which gives us minus 6. And some of you may see from here that if you have 10x, and in one case you're subtracting 7, but in the other case you're subtracting 6, there's no way that you're going to get the same number. But once again, we can just go through the work here, and you'll see you can subtract 10x from both sides, and let's say add 7 to both sides. And the 10x actually cancels in both locations. So what you wind up getting is 0 is equal to 1, and those are not equal. You get 0 on the left and 1 on the right. These are not equal values, okay? So we have no solutions here. Okay, so these would be an equation that could have no solutions. Now we could have an equation that has an infinite number of solutions. Okay, so what does this mean? This means that no matter what we plug in for x, the left side will always equal the right side. So this is saying it's not possible for the two sides to be equal. This one is saying the two sides will always be equal. So the left side always equals the right side. No matter what you plug in for x. Okay, so let's think about an example of that. So we could have something as simple as x minus 2 is equal to x minus 2. And you can see that no matter what you plug in for x, if you subtract 2 from that, in both cases, right, you're going to get the same thing. But again, if you're not thinking so carefully about it, or if it's a more complex equation, right, because these are very simple equations, we're dealing with things that are linear. So here it can be easier to see. It might be that an equation just looks very different on each side, and it's hard to tell, so you actually have to go through and solve it. But what you're going to notice is here, if you want to get things over to both sides, over where you get the numbers over to one side, so we can subtract x from both sides, we can add 2 to both sides, but what happens here is actually everything cancels out, right? Because we have an x minus x here, and we have a negative 2 plus 2 here on both sides. So we actually wind up with 0 is equal to 0. So if both sides are equal, and I'll put in equal the same number because notice there are no x's here. That means that there are an infinite number of solutions. Okay, and notice what you're doing to x on the left is the same as what you're doing to x on the right. If we take another example, so I'll number this 1 and 2 just so that you see 2 different cases. If we have 2x plus 3x minus 5 is equal to x plus 4x minus 2 minus 3. Okay, you can see here that if we combine like terms on the left, we get 5x minus 5, and we actually get the same exact thing on the right. We get 5x minus 5 again. X plus 4x is 5x, and negative 2 minus 3 is negative 5. And the same thing happens, right? If we subtract 5x from both sides and then add 5 to both sides, we wind up with 0 is equal to 0 again. And sometimes it won't be 0 equals 0. So when we do different types of equations, not just linear, you might get something like 3 is equal to 3. Infinite solutions, meaning you could plug in any value for x and it will always work. The left side always equals the right. Okay, and a lot of other equations, that's not necessarily true. If it were 2x plus 1 is equal to 3x minus 2, there's only one value of x that will work. But here, this is saying any x value that you plug in will work. Okay. Okay. So now let's talk about inequalities. Okay. So what is an inequality? So we talked about this a little bit in order of operations when we were talking about expressions, and we said, well, expressions are things that are in equations and are not inequalities. And inequalities is when you have your two sides, but you're not saying they're equal to each other. You're saying they're not equal in some way. So there are 4 different ways that we can show that things are not equal. We can have, there are actually 5 different ways. I'm going to put this in black. So what is an inequality? So we're talking about 2 expressions that are not equal. Okay, and again, there are 5 different ways, 5 different types of inequalities. And in order to show them, I'm going to use x and 4, okay? So the first one would be to say that x is less than 4. So less than is the first type of inequality. Okay. The second one is to say less than or equal to. The next one would be greater than. So we would say x is greater than 4. The fourth one might seem obvious because we have a less than and a less than or equal to. So we have an x is greater than or x is greater than or equal to. And then the last one is just x is not equal to 4. And that's an equal sign with a slash through it. So these symbols you kind of just have to learn, okay? There are tricks. The way I always see it is a less than sign is the same as an L, okay? It goes in the same direction as an L. So whereas the greater sign is like a backwards L, so L for less than. Some people see it as if you've ever, this may be a little bit old, I'm not sure. If you've ever done like Pac-Man, people say that the Pac-Man always eats the larger number. If you have another idea of how to remember the different inequality signs, then please, 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 in our discussion board, please just post how you learn to remember it, because I think it would be helpful for everybody. But honestly, you just have to remember it, okay? Now, what does this mean x is less than 4? That means x could be any number that's less than 4. So, and it could be positive or negative. Okay, so -3 is less than 4. -1 is less than 4. 2.68 is less than 4. So it doesn't have to be an integer. It could be any number, including our decimals. 0.62 is less than 4. Now, less than or equal to 4 is the same thing, but we're also saying that 4 is okay. Whereas in this first one, over here, we're saying 4 is not okay. Here we're saying 4 is okay because we have that equal sign. We're also saying in both of them that 3.9999999 is okay. So don't forget that it's not just the integers. So the decimals all the way up until 4 work, okay? The greater than is the opposite, right? We're saying that it has to be a number that's greater than 4. So 4.00001 works. And a million works as well, because those are two numbers that are greater than 4. Now, it's not going to be a negative number because every negative number is less than 4. So you're not going to see a negative number as being an answer here, okay? And again, the greater than or equal to says 4 is okay here, but 4 is not okay in this third one, okay? Now, not equal to 4 just says the only number that is not okay is 4. So 3 is fine, 7 is fine, -8 is fine, +8 is fine, 3.99999 is fine, 4.00001 is fine. 4 is not part of that solution set. Okay, so this is what we mean by an inequality. And when we solve these equations, we're looking for a final answer that looks something like this, that has x is less than or greater than, less than or equal to, greater than or equal to, or not equal to some other number. Okay, so it's the same thing that we have an x on one side and a constant on the other, just like all of our other equations. Okay, and it turns out that you actually solve inequalities in the same way that you solve equations. Okay, so a couple of things to sort of indicate that is something called the addition. We have the addition property and the multiplication property. This is just it's exactly what we say about equations, that if you add something to one side, you need to add it to the other. Okay, that's called the addition property. The multiplication property says if you multiply the left by something, then you have to multiply the right by something. Okay, so I'm just going to write that down so that you have it. So these are the addition property for inequalities. So this just says if A is less than B, then A plus C is less than B plus C. Okay, so that inequality is preserved. It doesn't change if we add the same thing to both sides. Okay, and this would be true for greater than, less than or equal to, greater than or equal to. So I'll add in the greater than, but I won't put in the equal to. But it is the same for all of them. Okay, if you add the same thing to both sides, you're preserving the inequality. And the same thing for the multiplication property. Also for inequalities, this is true for equalities. So if A is less than B, then A times C is less than B times C. And then the same thing for greater than. A times C is greater than B times C. There's one exception, right? And that exception is if C is equal to 0. Because if C is equal to 0, then when we multiply by 0, both sides become 0. And we wind up getting the same thing on both sides. So these would turn into equal signs. So except when C equals 0. Because anything times 0 is 0. Okay. Okay, so let's talk about solving inequalities, and then we'll do quick graphing, how to graph it on a number line, which some of you are going to be more familiar with. Okay, so like I said, it's exactly the same as solving an equality, solving an equation. There is only one difference. Okay, and the only difference is that when you multiply or divide by a negative sign, by a negative number, the direction of the inequality switches. So I'm going to write that down first, and then I'll show you an example and why that happens. Okay, so I'm going to put this in red because it's just I want you to remember it. So you solve inequalities in the same way that you solve equations. Except when you multiply or divide, so I'm going to put just a slash divide because this is true for either one, both sides by a negative number, the inequality switches direction. Okay, and what we mean is a greater than becomes a less than becomes a greater than, and a less than or equal to, or a greater than or equal to, will become a less than or equal to. A less than or equal to will become a greater than or equal to. Now, a not equals just remains as not equals. You don't have that problem for those. Okay? Okay, let's do a bunch of examples. But actually, let me do one example where that happens. So I'm just going to number these. So these are our examples. So for example, let's say that we have negative x is less than 10. Okay. Now we have two ways of solving this. One way to solve it is a shortcut. We can divide both sides by -1, right? There's an invisible 1 in front of the x. So if we divide both sides by -1, that makes the x positive, and our answer becomes x is greater than 10. If negative x is greater than -10. If negative x is less than 10, then x has to be greater than -10. Okay? Now, this is not the only way to solve this. We could have done it this way. But you'll see this is a lot longer. We could have said, okay, we want to keep the x positive. So in order to keep, right, that's our goal, is to get a positive x. So if we had wanted to, instead of dividing both sides by -1, we could have just added x to both sides. Okay, and what we get, I'm going to do this in 2 steps, even though we've been doing it in 1. We get 0 on the left, and we get that 0 is less than 10 plus x. But that means that we need to get the 10 over to the other side. So we can subtract 10 from both sides. And once again, we get that -10 is less than x, which is exactly what this says. Okay, these are the same. The -10 less than x, x is greater than -10. Notice the x is on the greater than side. Okay, so in both of these, we're saying that x is greater than -10. But notice this is a much shorter method. So this is a shortcut that says, hey, we don't have to bring the x over to the other side. Instead, we're just going to flip the inequality to show you that it winds up on the other side. Okay. Okay, let's do a bunch of other examples just of solving inequalities, and then I'll show you how to graph them. So let's do 2x minus 6 is less than 3x plus 1. We're not going to do a lot of these because this is exactly what we would do when solving equations. So clearly it's in our interest to keep the x positive. So ideally we would, instead of moving the 3x to the left, we would move the 2x to the right. So we would subtract 2x from both sides. And because we're moving the 2x to the right, we're going to take the 1 from the right and subtract it so that we get it on the left side. So the 1 goes away here, the 2x goes away here. And what we wind up getting is -7 is less than x. Okay, and this one I'm actually going to do the other way also. I'm going to do it so that we bring the 3x to the right and move the 6 to the left, just so that you can see what happens when we wind up with a -x. Okay, so I'm just going to rewrite this. I'm only going to do this once. Okay, and this time we're going to bring the axis to the right and then constants, the numbers, to, we're going to bring the axis to the left. I'm not sure if I said it that way. The axis to the left and the numbers or the constants to the right. So that means that we're going to subtract 3x from both sides instead. And we're going to add 6 to both sides. And you can see that the 6's cancel on the left and the x's cancel on the right. And now what we wind up getting is negative x is less than 7. And here, because we didn't keep our x positive, we have one extra step. We have to divide both sides by -1. And because we're dividing by a negative number, we flip the inequality. So don't forget to do this. So we wind up with x is greater than -7. Okay, so we get the same thing. In both cases, the x is on the greater than side, right? So here you can see that this opens up to e to our x. Here it also opens up to e to our x, okay? And the -7 is on the less than side. It's at the point in both cases. Here, because we divided by the -1, we had to flip it. It went from a less than sign to a greater than sign. So it was an extra step. So this is why we have that rule, because it saves us the trouble of moving the x to the other side. Okay. We'll do 2 more examples like this. So let's say, suppose that we have -5r plus 5 is less than 10. So this is similar, right? We want to get the constants over to one side. The variable is already on one side. We don't have to move that over because we don't have a variable. We don't have a variable on the right, so it doesn't make sense to worry about that. We don't have to move it over anywhere. And notice our variable is r. That's fine. We can switch variables all the time. Okay. So we subtract 5 from both sides. Here we get -5r is less than 5 now. Okay, and again, it's negative, so instead of adding it to both sides to get it over to the other side and make it positive, we just divide both sides by -5. And remember, when we divide by a negative number, the inequality sign flips, so it becomes r is greater than, and 5 over -5 is -1. Okay, and essentially what this is saying is if you plug in any value greater than -1, the inequality holds true. So let's just write that down. So if you plug in any value for r, that is greater than -1, the inequality holds true, which means that the left side is less than the right side. Okay, if we plugged in 0, that's greater than -1. We get 5 is less than 10. That works. 5 is less than 10. Okay. If we plugged in -1, it wouldn't work. Okay. If we plugged in -1, we would get 10 on the left, and 10 is not less than 10. 10 is equal to 10. Okay. Let's take one more example like this. And then we'll add on just a little bit. And when we add on a little bit, we're not adding on any more past that. So we have 2 times 3x plus 1 minus 7x is less than or equal to 2x. Now remember, we're not adding on anything here. We already know how to do this. And again, at this point, I recommend that you stop the video, you try to solve it yourself, okay? And then when you think that you have it, you start the video again and you just make sure that what you did is that you're getting the same answer, okay? So here, if you remember, our goal is to get rid of parentheses first. So to get rid of parentheses, we distribute that too. And once we get rid of parentheses, then we can combine like terms. Okay, and you should note that we're going to be doing stuff like this all the time where we're simplifying an expression, and the first thing to do is to get rid of parentheses. And to get rid of parentheses, it's always distribution. So 2 times 3x gives us 6x. 2 times 1 gives us 2. So we get 6x plus 2 minus 7x is less than or equal to 2x. And then combining like terms, 6x and negative 7x is negative x. Plus 2 is less than or equal to 2x. And since we have an x on the right without any constants, kind of makes sense to bring this x over to the right and leave this constant on the left. You don't have to do it that way, but it kind of makes the most sense. So we add x to both sides. This x cancels. Notice that leaves the constant by itself and the x by itself. We get that 2 is less than or equal to 3x. And we divide both sides by 3. And here we're dividing both sides by 3, but 3 is a positive number. So our inequality doesn't switch. So we just get that 2/3 is less than or equal to x. And that's our answer there. Okay. There's one other type of inequality, and it doesn't actually make anything more difficult. It's called a compound inequality. Okay. And essentially what this is that we have 3 sides instead of just 2. Okay, so I'm just going to go through 3 examples just so that you see it and how it works. So the first example looks like this. It would be -5 is less than 10x plus 10 less than 20. And what this is saying is that the value of 10x plus 10 is somewhere between -5 and 20, right? So instead of it being every number greater than -5 or every number less than 20, it's somewhere in between there, okay? So it's a range of numbers. So this is saying up here, -5r plus 5 can be anything that's less than 10, anything. It could be negative infinity. Here we're saying, nope, that's not true. It has to be between the 2 ends. Okay, and the way that you solve this is instead of doing something to one side, you're doing it to all 3 sides. Okay, you can break up this inequality into 2 inequalities. I wouldn't recommend doing that. Okay, you can break it up so that you have -5 is less than 10x plus 10. Solve that, and then solve 10x plus 10 is less than 20. The problem with that is it's doing extra work. Okay, you're doing extra writing. And when you break something up, you have to put it back together again. So you're doing a lot of this extra stuff for no reason. So the way that you solve this is we still want to get the x by itself. So we need to get the constant out of the way here. So see how we have this plus 10? So in order to get rid of it, we're going to subtract it. But this time, what we do to one side, we have to do to all sides. So we subtract 10 from every side. Oops, sorry about that. Okay, and if we subtract 10 on the left, negative 5 minus 10 is negative 15. In the middle, now we just have 10x. And on the side, we have 10. Okay, and now we need to get rid of this 10 in the middle. So we get rid of the 10 by dividing both sides by 10. I say both sides, but I really mean all three sides. Okay, and keep in mind that you want to reduce your fractions. So negative 15 over 10, both the top and the bottom are divisible by 5, right? So this simplifies to negative 3 over 2. Less than x, less than 1. Okay, let's do another example. 2 more examples, and then we'll talk about how to actually write your final answers. So let's do negative 2 less than or equal to negative 2x minus 12 less than or equal to 3. Okay, and it's the same process, right? We want to get the x by itself in the middle. So the first thing that we're going to get rid of is this negative 12. So we'll add 12 to both sides. Negative 2 plus 12 is a positive 10. So we have 10 is less than or equal to negative 2x, and 3 plus 12 is equal to 15. And now we just divided everything by a negative 2. And don't forget that we're dividing by negative. So all of our inequalities flip direction, right? So 10 over negative 2 is negative 5. And instead of a less than, we're going to have a greater than or equal to. And 15 over negative 2 just stays. Okay, and I want you to notice something. Negative 5 is greater than or equal to negative 15 over 2. Okay, negative 15 over 2 is like a negative 7.5. Negative 7.5 is less than negative 5. So that should always hold true, that the left side should follow this inequality with the right side. Okay, if we go back to the other one, negative 3/2 is in fact less than 1. Okay, if that did not come out that way, you made a mistake somewhere in here. Maybe you forgot to flip your signs. Okay, so don't forget to flip your sign. Okay, one last example just so that you see it a third time. Again, pause the video, try it on your own. Let's say that we have 4 is less than or equal to 8x minus 12, which is less than 30. So once again, we want to get the middle. We want to get the x by itself. So we're going to add 12 to both sides. I say both sides, you know I mean all three sides at this point. So that gets rid of the 12 in the middle. 4 plus 12 is 16, which is less than or equal to 8x, which is less than or equal to, less than 42. It is perfectly fine to have an equal on one side and a not equal on the other side, right? So here we have a less than or equal to. Here we just have a less than. That's fine. The only thing that you wouldn't have is a less than or equal to and then a not equal, you know, with the equal and the slash through it. You wouldn't have that in a compound inequality. Okay, and you wouldn't have a less than over here, but a greater than over here. That you would have to write as two separate inequalities because the 16 is less than 42. So you have to, if you take out the center piece, okay, the inequality should still hold true, and it does here. Okay, so then we divide by 8. Which gets rid of the 8 in the middle. We're dividing by a positive number, so nothing happens to the inequality signs. We get 2 is less than or equal to x, which is less than, and 42 is divisible by 2, and 8 is divisible by 2, so we get 21 over 4. And 21 over 4 is a little over 5, and 2 is less than 5. Okay, this is 5.25, so 2 is less than 5.25. Okay, so this is how we solve inequalities. But then we have special ways of writing the answer, and we can graph it. We can also do interval notation, so something called interval notation. So what I'm going to do is, I think I left enough space next to each of these. I left enough space next to. What I'll do is I'll go back and I'll show you how we would graph each of these and write the answer in interval notation. Okay, so let's do graphing first because the graphing will kind of lead directly into the interval notation. So graphing inequalities. And again, a lot of you are going to be familiar with this because this is just on a number line. We're not doing graphing on a coordinate axis. Okay, so the first thing to note is that sometimes we have things that are included, right? So like here, the 2 is included in our answer because there's a less than or equal to. The 21 over 4 is not because there's just a less than sign. Okay, so when we graph an inequality, what we're doing is we're saying, what is the range of our answers? And if something is included, we use one of two things. Typically, you probably remember it as using a closed dot. Because we're going to be doing interval notation, we can also use a parentheses, okay? So what we're doing is we're showing the range of values our answer falls in. If a number is included, okay, included meaning greater than or equal to or less than or equal to. So if you see greater than or equal to or less than or equal to, we use a closed dot or a bracket. So a closed dot would just be a filled in dot. A bracket would look like this, Or like this, depending on where we are in the range. So we'll do an example like that, okay, where you see both. If a number is not included, meaning a less than sign or a greater than sign, so no equals, then we use an open dot or a parentheses. So be consistent. If you're using brackets, use parentheses. If you're using dots, then only use dots. In other words, don't use a parentheses and then a closed dot for something else in the same graph. Okay, so let's just do a bunch of these, okay, just so that you become familiar with it. Let's go to the next page. So for example, let's say that we had x is greater than or equal to 3. So what we would do is we would draw a number line. And the only thing that you really need here is the 3. You don't even need the 0. Some people like to put in 0 so that you're showing what side of 0 you're on, but you actually don't even need that, okay? But since so many people feel comfortable putting it in, let's stick it in there. So the 0 could go anywhere on the number line. 3 is on the right, so we can put the 3 here. You don't even have to mark off 1 and 2. It's not necessary, okay? Now x is greater than or equal to 3. So greater than or equal to is to the right, right? 4 would be greater than or equal to 3. 5 would be greater than or equal to 3. Whereas any of the numbers in between here or on the left, that would not be the case, okay? So we're looking for everything that starts at 3 and is above, greater than, okay? So we have two different ways of doing this. I'm going to do it with the brackets, okay? But you can do it with dots. So the bracket should face, notice we're using a bracket because there's an equal sign. And the bracket should face the part of the graph that you're going to wind up shading to show that it's over there. So I like to do this in different colors so that it's really clear, but you can just shade it really darkly too. So greater than 3 we would have a bracket that goes through 3. It's greater than because there's an equal sign. And then you're going to shade everything to the right. And make sure that you put an arrow because what you're doing is you're saying it's everything greater than 3. Okay. And that's how we would do it. If you were doing it with dots, I'm only going to do this one with dots. You are welcome to do it with dots, but you'll see why I choose not to. This is a 3. The 3s on this pad don't come out very well, so just be aware of that. That's why I always say the numbers. So in this case, you don't have to worry about the direction of the bracket because it's just a dot. So you would just draw a dark dot here. It's a closed dot because there's an equal sign. And then the rest of it would be the same. You're just shading. Okay. Okay, let's do another example. Let's say that we said x is less than -2. So if x is less than -2, then again, you can put in the 0. And then we have a -2. -2 is to the left of 0. And notice there's no equal sign. So if you were using dots, you would just put an open circle. I'll do this one with a dot too, just so that you see what it looks like with an open circle. And we want less than. Less than means to the left, okay? So less than is over here. So we're shading this area. And because there's no equals, we're going to use a parentheses. So remember, the parentheses and the brackets are going to open up in the direction that you're shading. So our parentheses is going to look like this. Sorry, I should do this in a different color. And again, let's do it with the open dot just so that you see what an open dot looks like. So we have -2 to the left of 0. And an open dot is just essentially, it's exactly that. It's a dot that isn't filled in. So just make sure that it's really clear that your dot is open, right? So don't draw it too small because then it'll be really hard for me to tell or anybody else to tell. And then the same thing happens, you shade. Okay. Okay, let's do another one. So this one I'm only going to use parentheses and brackets. So let's do what it looks like if it's a compound inequality, right? If it's a range of values, if x falls between two numbers. Okay, so -3 is less than x, which is less than or equal to 1. So if we're doing this, now again, you really don't need the 0, okay? The 0 is just for context, but you don't need it. You could just put in -3 and 1. If you want to, you can do 0, but make sure that your 0 is located in a place that makes sense. Don't put it exactly in the middle, right? 0 is closer to the 1 than the -3. And then we're saying that it falls in between, right? It falls here in the middle. So here, x is greater than -3. There's no equal sign. So we're talking about a parentheses, and it faces the middle. And then at 1, 1 is included, right? We see an equal sign, so we're going to use a bracket. And again, it's facing the middle, and we just shade. Okay. Okay, let's go back to the problems that we did before and graph them. We did like 5 of them, 6 of them. So let's do this one down here. We're saying x is greater than -10. So let's just graph it. So again, we're going to do a number line. You can put in a 0 if you want. You don't have to. And then -10 is to the left. You don't have to label anything in between, so it doesn't really matter as long as it's to the left. This is a greater than. Greater than means on the right, so we're going to be shading this area. And there's no equals, so that means a parenthesis. So because we're shading to the right, our parenthesis is going to open to the right. And we put an arrow. Okay, next one. -7 is less than x. Or x is greater than -7, right? So here's our number line. You can put in the 0 if you want. You don't have to. And x is greater than -7, so we're talking about going to the right again. And there is no equals, so it's a parenthesis. Over here, at the next one, we have r is greater than -1. Sorry, we actually wound up with all greater thans. So it's really similar. We have our 0, we have our -1, and greater than is to the right, so it's going to be a parenthesis. There's no equals. It's a parenthesis because there's no equals, not because it's going to the right. Okay, this one also happens to be greater than. So we have our number line. You can put in the 0, you can put in the 2/3. Here, x is greater than again, so we're going to the right, but notice here there's an equals. So that's a change because instead of using a parenthesis, we're using a bracket. Now we have our compound inequalities. So on our compound inequalities, we have -3/2 and 1. And I'm actually going to leave out the 0 here. It's just not necessary. And that way I don't have to think about how things are spaced. And remember, in this compound inequality, you're shading the middle. It's just a matter of, are you using parentheses on the end or are you using brackets? And here, both of these are less thans. Neither one has an equals. So we're using a parentheses in both cases. They're just facing in opposite directions. Here we're facing the middle. Here we're facing the middle. And then we just shade it. The next one. So just be careful with this next one, because remember that these are greater than. The -15/2 actually comes before the -5. So just be very careful about that. And in this case, both have equal signs, so we're using brackets in both cases. And it's a compound inequality, so they both face the middle. Okay. And then finally, the last one, we have 2 and 21/4. And here, with the 2, we have a bracket because there's an equals. With the 21/4, we have a parentheses because there is no equals. And again, they both face the center. So we have a bracket on the left, a parentheses on the right. Try and do your best to make it really clear that this is a bracket and this is a parentheses. So make it clear that you have your straight line and then your curved line. Just do the best that you can. Okay. Okay. One last thing. The last thing is something called interval notation. And this is really simple now because we already graphed. So interval notation gives you a range of values, and it's essentially the same exact thing as our graphing. So a bracket says the number is included. A parentheses says the number is not included. And it's always the smaller number, comma, the larger number. And if you remember in the last lesson where we talked about solving equations for absolute value equations, and I said it's a solution set, you might want to get into the habit of putting the smaller number first, even though it doesn't matter for that. Here it matters, which is why I said you might want to get into the habit. So it's always the smaller number, comma, the larger number. Okay. And then infinity or negative infinity always get a bracket. Sorry, a parentheses. Okay, so let's just go through each of these and write it in interval notation. So here we have x is greater than or equal to 3. So 3 is the smallest number in the range, okay? And since it goes on forever, infinity would be the largest number in the range. So I'm going to put the interval notation in blue. So 3 is the smallest number, and it's included, so it gets a bracket. You write 3, and then it goes to infinity. and infinity always gets a parentheses. Okay, so notice it looks just like the graph, right? Which is why on the graphing inequalities, I like using the brackets and the parentheses because then it looks exactly the same. Here, this is a less than. So the smallest number, remember we read left to right. So it's easy to know what's smallest and what's greatest, okay? Here you're looking at you're starting at the very left. That's the first number, okay? And then you're going all the way to the right. Your last number is infinity. Here, when we start at the left, we're all the way at negative infinity because this just keeps going this way, okay? So now it's negative infinity, and negative infinity gets a bracket. Sorry, a parentheses. I don't know why I keep doing that. And then the largest number in our range, if we go all the way to the right, is -2. And that also gets a parentheses because it's not included. Now this is our range. So this tells us exactly what the interval notation should be. We start at -3 and it tells us there's a parentheses. And then it goes to 1, and at 1 we have a bracket. And if we go back to the other problems that we had, -10 less than x, you can see that we started with a one ahead. You can see that we start with a parentheses on the left of our shade, and then we go all the way to infinity. So this would look like this. -10, comma, positive infinity. Both get brackets, both get parentheses. Okay, this one is x is greater than -7, same thing. You get parentheses, you go from -7 to positive infinity. Down here, same thing, you go from -1 to positive infinity. Here, this is x is greater than or equal to 2/3. So if we look at our graph, you're going from 2/3, and that's a bracket. So it's 2/3 to positive infinity. Now, the only place where you don't have infinities is with compound inequalities. So here, our smallest number is -3/2. That's the beginning of our range, and it goes to 1. That's the end. That's the highest number. And they're surrounded by parentheses. So it goes -3/2 to 1. And then the last two that we did, again, same thing. You can see that this tells us what it looks like. We're going to have two brackets, and it goes from -15/2 to -5. And then the last one, we start at 2. We end at 21/4, and you can see we have a bracket first, then parentheses. So that's interval notation. And set notation is, I like this better actually, but most of the time you're going to be told to use interval notation. So I just want to show you what set notation looks like. It's easier to use, I think, because all you're doing is you're writing your answer. So set notation has two braces, and you have x or whatever variable you're using. So in one of the cases we had an r, so you would use an r. And then you have a line. That line means such that, I'll write that in a second, and then you just write your answer. So it might be x is greater than or equal to 3. I'm going to write solution here. But I'm going to go back up and write it out for you in all of the other cases so that you see what we mean when we say solution. So this means such that. It's essentially saying x could be anything except, or as long as it's this. Okay, x can be anything as long as it satisfies your solution. So up here, your set notation, which I'll put in green, would just be an open brace you would write x such that -3 is less than x is less than or equal to 1. This one would be x such that x is less than -2. And this one would be x such that x is greater than or equal to 3. So when we get to some more complicated, not really complicated equations, but equations where we have multiple solutions or multiple inequalities, we're going to prefer set notation, okay? Here, interval notation is actually a lot shorter to write. Here, it would be x such that, and then just our answer. Okay, here, x such that -5 is greater than or equal to x, which is greater than or equal to -15/2. You could rewrite it as -15/2 is less than or equal to x, which is less than or equal to -5. It's not really, doesn't really matter though. Okay, and then we have the others. X such that -3/2 less than x less than 1. X such that you can write it as x is, I'll write it as x is greater than or equal to 2/3. Kind of get into the habit of writing the x first. It's just a good idea. If we go to the second problem, let's go to this third one. Okay, here we're going to write an r because that's our variable. And we would just write r is greater than -1. Here we have x such that x is greater than -7. And in the first problem that we did, we would write it as x such that x is greater than -10. Okay, so this is set notation. This is interval notation. I don't care which one you do. I don't care. But I can tell you that you want to be familiar with both. Okay, it's important. You should be familiar with both. But in most cases, I don't care which one you write. And that is it. Until next time.